In our previous session, we have discussed what are electrochemical cells and the terminologies used in electrochemistry like electropotential, standard electropotential, and free energy entropy. And we also seen what do we understand by oxidation, reduction, etc. So before going to derive Nernst equation, I'll just brief what is oxidation and reduction. So if a metal loses electrons, it is called as oxidation. Loss of electrons is called as oxidation. Gain of electrons is termed as reduction. So you might have studied in your plus 2 in a different way in terms of hydrogen, but here electrochemistry, it is completely in terms of electrons. I repeat, loss of electrons is called as or is termed as oxidation, and gain of electrons, that is metals, gain of electrons is termed as reduction. Okay, with this brief introduction, let's start the derivation of Nernst equation. So in order to give the relationship between the concentration of the species in which the metal is dipped in and the electrode potential of the metal, Nernst, a German physicist and chemist, formulated the Nernst equation. Okay, so the Nernst equation gives the relationship between the concentration of the species in which the metal is dipped in and the electrode potential. So let us see how Nernst derived the reaction or came to the final conclusion. So in order to derive Nernst equation, Nernst considered the following reversible reaction, that is Mn plus, that is general metal, plus n electrons gives m. So it is a reversible reaction. The forward reaction is the reduction reaction and the backward reaction is the oxidation reaction. Since the reaction is in equilibrium, so there exists a equilibrium constant K. So according to thermodynamics or physical chemistry, the equilibrium constant K is given by concentration of products by concentration of reactants. So from the above equation, it is clear that concentration of products is M and the reactants is Mn plus. So K is given by concentration of M by concentration of Mn plus. So let us call this equation as 1. So for any reaction which occurs in the in the universe, it will be accompanied with decrease in free energy. So the decrease in free energy will be given by delta G equals minus W max, where W max will be given as minus NFE. Okay, so delta G equals minus NFE and delta G naught is also equals minus NFE. So any reaction which occurs in the universe is given as delta G equals that is decrease in free energy. Okay, so where delta G equals gives free energy and delta G naught equals standard gives free energy. From Van 't Hoff's equation we have delta G equals delta G naught plus RT ln K, where delta G gives free energy, delta G naught gives free energy, R is gas constant, T equals temperature, K is equilibrium constant. Substituting equation 1 and 2 in the above equation, we get minus NFE equals minus NFE naught plus RT ln concentration of M by concentration of Mn plus, where N is number of electrons, F is Faraday's constant, E is electrode potential and E naught is standard electrode potential. So what we want? We want E, the electrode potential, which is related with the concentration of the species of the in which metal is dipped in. On the left hand side we want electrode potential and right hand side we want the metal species, concentration of metal species. Both we have. But what do you have? With that we have the extra fittings minus NF on both the sides. We are supposed to remove that extra fittings. So how to remove that extra fitting? We're going to divide the entire equation by minus NF. So when you divide the entire equation by minus NF, we get E equals E naught minus RT by NF ln concentration of Mn plus by concentration of M by concentration of Mn plus. So here we are supposed to convert natural log to log. So how to convert? It is a simple mathematics. I am going to change the negative charge to positive charge. So now changing the negative charge to positive charge, I'll tell you first one by one. So ln ln to log. How do you convert ln to log? So multiplying by 2.303. When you multiply 2.303, ln will become log, log. Right. So in order to make the entire equation positive, we are interchanging the sign. Okay. We are interchanging the sign. That is, numerator will become denominator. That is, log a by b equals minus log a by b. A simple basic mathematics. So when we are applying this there, we get E equals E naught plus RT by NF 2.303 log concentration of Mn plus by M. So changing the sign and converting ln to log, both is done in the single step. So now substituting for R, T and F. It is at temperature 25 degrees Celsius. R is 8.314, that is gas constant. F is Faraday's constant 96,500. Substituting for all this in the above equation, we get E equals E naught plus 0.0591 by N log concentration of Mn plus by concentration of M. So this is the Nernst equation for which is having two cells. So if you are having only one cell for a half cell, so zinc is dipped in zinc sulfate, copper is dipped in copper sulfate, silver is dipped in silver sulfate. Only one cell, half cell. So how to determine the electrode potential? So anyhow you have arrived for a Nernst equation which relates what? Electrode potential and the concentration of the species in metal is dipped in. But if you have a single metal, then how to determine the electrode potential of that? For that, so let us consider concentration of M equals 1. So if concentration of M equals 1, then we get E equals E naught plus 0.0591 by N log concentration of Mn plus. So this is the required Nernst equation for single electrode. So as we know, E is the electrode potential, E naught is standard electrode potential, N is a constant. It is not constant. N is number of electrons lost during oxidation or gained during reduction. So this N can be known only by writing redox reactions, anodic and cathodic reaction, or the overall reactions. And Mn plus is the concentration of the species. So if zinc is dipped in zinc nitrate, the concentration of zinc nitrate. Okay, or silver is dipped in silver sulfate, the concentration of silver sulfate. The concentration of the salt solution in which metal is dipped, that is Mn plus. By this, we can determine the electrode potential of single electrode. So this is how Nernst proposed the Nernst equation for single electrode as well as for a cell. So Nernst is a great physicist and chemist. When he proposed the Nernst equation, his age was around 25. So in future, he has contributed too much to thermodynamics and he was awarded Nobel Prize too. Thank you.